Hello everybody and welcome to this new tutorial. If you remember, a few months ago I made a tutorial about writing an FA1.2 contract in Michelson. So today we are going to write a very simple FA1.2 contract using CameLigo. The contract that we are about to write is going to implement the standard features of Tezos 7, and you will see that it's a lot easier to write that contract in Ligo than it is to write it in Michelson. At the same time, for this tutorial we are going to use the web ID provided by Ligo, so you can have a better idea about how it works and how it looks like. So let's get started. The first thing to do is to write the type for the parameter for the transfer entry point. We are going to expect two addresses and a NAT number. On the CameLigo side, we can create a record with the from property that's going to be the address of the sender, a to property with the address of the recipient, and an amount property for the amount of tokens that are going to be transferred. The second entry point of our contract is the approve entry point that requires two parameters, a spender address and the value that's allowed to be spent by the spender. So we are going to use a record in CameLigo to represent those parameters with a property spender that represents the address of the spender that's going to be allowed to spend the tokens, and the value property for the amount of tokens that is going to be allowed to be spent. Now we can create a type for our storage. In the storage, we're going to have a ledger to keep track of the balances and the allowances, and we will also keep track of the total supply. We will represent that with a record, with the ledger property, and the total supply property. And in order to make it easier to work on the CameLigo side, we are also going to create a type for the value that's inside the ledger. That value is a record with the balance property of type NAT and a map that represents the allowances. To finish, we can create a result type that's going to represent the result of the execution of each entry point. That is a tuple that's returned with on the left a list of operations and on the right the new storage. After preparing all the types that we are going to need in our contract, we can start writing the first entry point, the transfer entry point. So the goal of the transfer entry point is to be able to transfer the tokens from one balance to another. And we are going to check how to do that safely. The transfer entry point takes a parameter of type transfer param, a parameter of type storage, and it's going to return a value of type result. The first thing that we do here is to destruct the record of the transfer parameter, just to have a clear name of the values that we are going to manipulate next. The first thing that we are going to check during the execution of this entry point is whether the spender exists in the ledger. If the spender doesn't have an account, there's no reason to continue the execution because there are no tokens to transfer. You will use here pattern matching and the bigmap.findOpt method in order to check if the spender exists in the ledger. If it doesn't, it's going to return none, and then we can make the contract fail. Otherwise, we are going to return the account and then we can continue working with that value. Now, the idea is to check if the spender has enough allowance in order to make the transfer. We are going to check first if the spender's address is the same as the sender's address. In that case, there is no allowance to check, and we can just return the current allowances and continue with the execution of the contract. Otherwise, we are going to check if the sender is allowed to spend the tokens. In order to do that, we are going to check inside the allowances map if the spender's address exists. We can use the map.findOpt method in order to do that. If it returns none, it means that the spenders doesn't exist in the map of allowances, and thus they're not allowed to make the transfer. So we can make the contract fail with the not enough allowance error message as specified by the Tezos 7 standard. If the spender's address exists in the map of allowances, we have to check that the spender is allowed to spend the amount of tokens that is required for the transfer. If the allowance for this spender is less than the amount of tokens that is required for the transfer, then we are going to make the contract execution fail and return the not enough allowance error message as specified by the standard. At the same time, we also return the amount that was required and the amount that's present in the allowance map. If the allowance in the ledger is greater or equal to the amount of tokens to transfer, then we are going to update it and return the new allowances. The safest way to make a subtraction in Ligo is to use the isNat method and to pass the result of the two values that you want to subtract. The isNat method is going to verify that the result of the subtraction is a natural number, so it's 0 or a positive number. If the result of the subtraction is a negative number, then pattern matching on isNat is going to return none, and we want to catch that and make the contract fail. In this case, it's a pretty simple example, and we already checked that the allowance is greater or equal to the amount. So the probabilities of having a negative number here are very, very small. But anyway, it's a good habit to take, and you should use isNat in order to check that the result of a subtraction is a natural number if the use case dictates it. Once we get the new allowance, then we can update the map of allowances and return it with the updated allowance for the spender. The first thing to do at this moment of the execution of the contract is to verify if the spender has enough balance. So we are going to use again the isNat method in order to subtract the amount of tokens required for the transfer from the balance. If the amount returned is a negative number, it means that the spender doesn't have enough balance and we can make the contract fail with the not enough balance error message. Otherwise, we are going to get the new balance and we can update the ledger and pass the new balance to the bigmap.update method in order to update the balance of the spender. After that, we are going to get a new version of the ledger with the updated balance. After that, we can add the amount of tokens to the balance of the recipient, and we can return the new ledger after it's done. First, we are going to check if the recipient is present in the ledger by using the bigmap.findOpt method. It will return none if the recipient doesn't have an account, so we can create one with the bigmap.add method and pass the address of the recipient, the balance, creating an empty map for the allowances, and return the new ledger. If the recipient already has an account, then we have to add the amount of tokens to the existing balance. That's what we do with the bigmap.update method, and we perform a simple addition with the existing balance and the amount of tokens that was transferred. To finish with the execution of the transfer entry point, we return an empty list of operation and the new ledger. Now let's see what happens with the approve entry point. The goal of the approve entry point is to set an allowance for a spender in order to spend tokens on behalf of another user. As I want to keep this tutorial pretty simple, only the people who are going to send transactions directly to the contract are going to be allowed to update their allowances. But know that the standard is pretty flexible and you can also have different behaviors if you want third parties to update allowances. The first thing that we do here is to create a variable to store the address of the sender. So it's going to be easier to manipulate in the rest of the code. Now we are going to update the ledger. So we are going to look for the address of the sender and use the bigmap.findOpt method in order to find it. If we don't find it, it means that the sender doesn't have an account in the ledger, and then we're going to create one. The TZIP7 standard allows to set allowances even for users who don't have a balance. So in that case, we know that the sender doesn't have an account in the ledger, so we are going to create a new account with an empty balance, and we can set the map of allowances with the values that the sender provided. Now, if the sender has an account in the ledger, we are going to update the allowances map in two different ways. The first way would be if there's already an allowance that's set for the spender's address, and the second way is just to create a new allowance for the spender's address if there's not already one. We are just going to use pattern matching and the map.findOpt method in order to check if the spender's address exists in the allowances map. If it doesn't exist, then it is the easiest case and we just create a new entry in the allowances map. If it exists, then we are just going to add the new allowance to the existing allowance. Before updating the allowance, we have to check the current allowance in the map. It is forbidden by the TZIP7 standard to update a non-zero allowance with a non-zero value. Doing that would create a safety issue, and that's something that you want to avoid. So you have to check that if the allowance present in the allowances map and the value that's set for the new allowance are both non-zero values, the contract has to fail with the message unsafe allowance change. Otherwise, you can continue and perform the change of allowance and then return the new account with the updated allowances. To finish, you can use the bigmap.update method and insert the new account for the sender. And now you have a new ledger. Once the new ledger is ready, we can return a tuple with an empty list of operations and the new storage with the new ledger. Now, the moment of truth, we are going to click on the compile button and see if our code compiles properly. Fingers crossed, and that's it. Here you can see that the Mikkelsen code has been generated and everything is fine. And that is it for this tutorial. You can see that writing a simple FA1.2 token contract is pretty easy. Ligo also makes it a lot easier, and there are just a few things that you have to take into account, like for example checking balances and allowances, and also making sure that you don't make any unsafe allowance change, and you can write it pretty easily and pretty quickly. The FA1.2 contract is one of my favorite exercises for beginners in the Tezos ecosystem because it's pretty easy to write and it introduces some key features of writing smart contracts on Tezos. I hope you enjoyed this tutorial. If you have questions, don't hesitate to leave a comment. If you liked it and want to see more tutorials, don't forget to like and subscribe, and I will see you in the next one.